Hi, morning guys. I'm back here with another tutorial. Today I'll be going through tangents. And first let me explain to you what's a tangent. In geometry, the tangent line to a plane curve at a given point is the straight line that just touches the curve at that point. So if you have a curve, any circular object, this circular object as we can see, and wherever this line touches, so at that point here, where the line barely passes and touches the circle on its circumference, that line will be considered, this interaction will be considered a tangent. Okay, so what we are going to do today, I'm going to go through a question from a past CXC paper where I'm supposed to create an internal tangent between two circles. So the first circle is going to be radius 12, the second circle is going to be radius 26, and the distance in between is 120 millimeters. So let's start with that now. I'm going to start setting it up around here. So let me just draw a datum line. I usually like to draw my datum line and grab my compass, and like I said, the first one, the smaller circle, is radius 12. Just find a convenient point to start, and I'm going to draw a circle at radius 12. So radius 12 will mean diameter 24, because 12 plus 12 is 24. Right, now we got to separate these circles 120 millimeters apart. So on your set square, that will come in as 12. For those of you who are totally unfamiliar to this process, when we speak of 120 millimeters, we're just looking for 12 on this set square, right? Now, so this is point L. The axis of this circle is point L, and the axis of this circle is point O. What I'm going to do now, I'm going to draw my radius 26 circles. That's 25, 26. Found radius. I'm going to put in my two circles dark so that you guys at home watching this tutorial will be able to see properly. Because I found sometimes when I review my work, it's a bit light and people might not be able to see all the steps that I'm making here. So I hope that's bright enough for you guys viewing. So now this is O, this is L. And what we're trying to do now is we're trying to put these two into a tangent, whereas we need to get a line from here going to there. Now the first thing, we got some steps here. So the first thing we need to do is we need to divide this and find a midpoint. So this is where we bisect. So I'm going to bisect the distance between L and O. To do that, we just take our compass and open it past what we would consider more than half, but always less than the full distance. The full distance is L to O. Halfway will somewhere be around here. So we open the compass anywhere more than half and in between the full distance. We make an arc above and we make an arc below at O, and we do the opposite at L. Make an arc above to correspond with the arc above from O, and the arc below at L to correspond with the arc from O. So you should have four lines, you should have two X's. And all you are doing is you are drawing a line from the below X to the above X. And that actually is how we bisect a line. Bisecting, when we say bisecting, we mean dividing the line into two equally. So at that point, we're going to call this now point M. That's the middle point. Let's call that M. And at M, I'm going to stop M, go to L, and I'm going to create an arc which should naturally end at O, because this is half. Getting a slight error, so I'll just erase this and and go again. I know where the error is. I don't think these bisection points, I don't think this is going through the direct center. Let me line that up there. Yeah, that's more of a okay, good. Alright, so that's our arc there. Cool. So the next thing we need to do now is we need to take the radius of this circle and subtract it from the radius of the other circle. So there's an old formula that when we are doing these, I'll explain to you now. Let me just go for my book, my reference material. Can never find the page when you want it, and I had the page there just before this demonstration started, you know. Anyway, here it is. So what we're trying to do is we're trying to put a circle on the outside, and to do that we need to create an imaginary circle, which is called our construction circle. To get that construction circle, what we need to do is we need to add circle O and circle L. So circle O is radius 26 and L is radius 12. So when you add the two of those together, you get 6 and 2 equals 8, 2 and 1 and 3. So that is a radius of 38. What do we do with that? At that 38, we actually take the bigger circle and we draw a circle of radius 38 there. And that would then be considered our construction circle. I'll show you why we need a construction circle. So I'll draw the circle rather light because it's a construction circle. And now that we have our construction circle, we are now taking our point from the construction circle that interacts with the semicircle that we drew when we bisected L and O, and that will be here. That's the point there. So now let's give that point a name. We have L, M, O. Let's call that P. So P will then connect to L. We connect P to L. So there is a real point, the axis of L connects to P, which is a construction point on the construction circle. What we're then going to do, we're going to track that, that line all the way down to the end of the circle, which corresponds to the edge of here. So we track the line. Let's go over that again. I'm tracking the line LP. When I say tracking, I'm carrying the properties of that line, meaning the angle, and so I'm transferring. The right term is called parallel tracking. So I'm parallel tracking LP to where it barely or just touches the circle, both circles. And if I do that successfully, they should touch both circles simultaneously. So, and this then is our final step. So what I've done is I've transferred LP from the construction circle to the real circles. And so that's the benefit of the construction circle. Things are projected from there to the real circle so that we get able to solve the problem. Now what I'm doing is I'm putting in my parallel lines to show my step, to show how I arrived at this line here. So these arrows represent parallel lines going in the same direction, and they will never meet. So that is it. Here we have our circle radius 12. I can just put that in, and I'll just go through this process again before we turn off. So this is circle radius 12. The distance between these two circles are 120 millimeters, 120 mm, and the radius for circle O is 26. So what do we do with this? We combine 26 to 12. Over here, that's what I did, and I was able to get radius 38. So we have here add radius 26 to radius 12, and you get 38, and 38 will now be my construction radius, which is here. This is my construction circle, the outer circle, the biggest circle on the page, and I'm going to label that as a construction circle. Construction circle. Alright. Cool. Two circles, construction circle, which is a combination of the two radii, and then we bisect the distance between L and O, find M, create a semicircle from M, semicircle spanning L and O with M in between, and we are looking for where that semicircle interacts the construction circle, and that's point P. What do? We send point P to point L, create a straight line, and then track that straight line of L and P to where it simultaneously touches these two circles. And then this is how we know that these two circles have been successfully placed into an internal tangent. Alright, thank you guys. I hope you enjoyed that demonstration, and look out for the external tangent. That's the next one that I'll be doing. So let me just label what this is that I've done. This is an internal tangent, and it should be obvious. The two lines go inside, so that's why we call it internal tangent, right? And that's it. Thank you.